Good morning, friends. Today we'll cover problem number 7, false sharing, in our tutorial series on top coding interview solutions in Java. So, what is false sharing? I think this is a very common interview problem which has been being asked if you are applying for a team which is relying heavily on core Java platforms where we have got multi-core systems. Almost all the production servers right now in running in any banks or any other technical company, they are having the multi-core CPU architecture. By multi-core CPU architecture, what it means is it's very much like this diagram that we have got multiple CPU. I'm just taking an example of simpler example of only taking two CPUs. Each of the CPUs having two cores, and each core has got its own thread. So the fastest way that to CPU to like fetch any data is from the register itself, but that is very small. Uh, so there are two possibilities for fetching the data from a cache. It can be a cache hit, which means that it's able to get the data from the cache itself, and if it doesn't get the data from the cache, then it's called a cache miss. In that case, it will go to the next level of the cache to fetch the data again. So just let's start. Let's take an example that we have got two CPUs, thread one and thread three. Sorry, and thread three is from this second CPU. And there are variables which are being stored. It tries like fetches from CPU register first, and if it doesn't get it go to L1 cache, and then finally to L2 cache, and in the worst case, it will go to L3 and main RAM. Similarly, it goes for the same line as here. But here you can see that there's one major thing which is here, that L1 and L2. These two caches are only pertaining to this thread one, this core one CPU registers. It is not bothered about the other cores or other threads relying on the same CPU or the other CPUs. But this L3 cache is a big cache, and it is common for all the threads from all the cores. It means that whatever the values are here in L3 cache and which are spread over L2 cache here and L2 cache here in this thread 3, that needs to be synchronized. And that synchronization process is called cache coherence. By synchronization, I means that whatever the value is there in this cache should be same as whatever the values in this cache, because they both are sharing from the same L3 cache here. Now, what is false sharing? False sharing in Java occurs when two threads running on two different CPUs write to two different variables which happen to be stored within the same CPU cache line. So what it means in this context is, suppose there are two variables. One is variable A here, and another variable is B here, but both are being read or written by thread 1 here and thread 3 here. Just take this example. But both A and B variable, A here and B variable, they are getting manipulated here in L3 cache as well, because L3 cache is common one for both thread 1 and thread 3. And suppose there is this thread tries to write this variable A here, but thread 3 is not doing anything on the B variable. It is just that thread 1 is manipulating the data at A. But because both A and B are sharing the same L3 cache line, in that case, although the thread 3 is not doing anything with the B variable, only thread 1 has manipulated the A variable, still the whole cache line would be invalidated by this thread 3, because it sees that while the cache coherence process, it will see that the variable inside this has been changed in the L3 cache, although it's not the B variable but the A variable. Still, it will invalidate the whole cache thread line, and then it has to refetch all the data from the main RAM back into L3 and back into this. So this is called false sharing. It's called false sharing because although the B variable is not manipulated here, only A is manipulated by some other thread, still it has to invalidate it, although it hasn't done anything on the B variable. To depict it more clearly, it's what we just discussed, that say suppose thread 1 is writing to A into L1 cache. Here we have got this A variable here, L1 cache, L2 cache, whatever. And the thread 2 is just reading this B variable. But because thread 1, both A and B are actually in the same cache line containing both A and B, And because thread 1 has manipulated this variable A, still the cache line would be invalidated, which means that it has to flush the data again from L3 cache and from the main memory. So this is fault sharing. Because the cache line normally it's like 64 bytes, and in some modern CPU architectures, it can be 128 bytes. But the idea is that our one long variable is 8 bytes, right? So it means that there's possibility that if we have got 64 bytes of cache line, it means that it can accommodate a total 8 long variables, because one long variable is 8 bytes in Java. It means that one cache line can be holding 8 long variables. So this is a very common. Suppose like A and B, both are like a long variable, and both are sharing the same cache line. It's very much possible, right? Because it has got 64 bytes, and in this case, we have only 16 bytes of memory occupied by these two variables, A and B, and both of them are on the same cache line. So this fault sharing is very much possible. Whenever this cache line is invalidated, all the line is marked dirty for the other caches. And that's why a read on a dirty line triggers a refresh of this line. This refresh is like very costly because it has to again flush the data from main memory. This can be a very, so if we are working on a low latency Java systems, where we are building very low latency market connectivity or automated system, I think this fault sharing is very dominant there, and it can severely impact the overall performance of the system. So in this interview problem, although it's like a tough one, but still, I would suggest that just go through just try the problem on your own. So first of all, we need to write a program to demonstrate fault sharing in Java. Just take the hint is that we have got 8 bytes of eight long variable, and just suppose that there are 64 bytes in your cache line, and then you have to write a program to demonstrate fault sharing. That is taking more. How can you demonstrate it? So you have to make a situation that the fault sharing happens and it's impacting the performance. So you have to measure the performance. And the follow-up would be to just modify the program to resolve fault sharing and then measure it again, whether it's improved the performance or not. So guys, just try this problem on your own. There are a lot of tutorials available. So go with that. Try this problem first. And in the next videos, we will solve the problem together. So see you all in the next video.